Hello everyone. The title of this session is Ractor speed is not write speed. This talk is about Ractor, a new feature of Ruby 3.0, and it's an application and about web applications. This is Satoshi Tagomori speaking. I am our freelance technical consultant from this summer after leaving a company, Treasure Data, this year. And I am our hobby Ruby programmer. And I am a member of Saxa RB, that is a regional Ruby meetup near Saxa, but then right now that is an online meetup. So yeah, and we are welcome to new people to the Saxa RB community right now. Of course, we are always welcome to the Saxa RB, but then especially now we are online. So yeah, you can join to the Saxa RB very easily. Anyway, I will talk about Ractor, a new experimental feature of Ruby 3.0 to run Ruby code in parallel on multi-CPU cores. And that is a very long expected feature, so that this RubyKaigi has 3 Ractor sessions. The first one is parallel testing with Ractors as the day 1 yesterday and this session. And the other is Ruby Ractor Quick at day 3 tomorrow. Yeah, Ractor's feature is to run Ruby code of multiple Ractors in parallel on CPU cores by managing objects per Ractor. The runtime runs in parallel on multiple CPU cores, needs to manage state concurrency, and needs to take care of multi-thread problems, so that the Ractor divides object space into multiple Ractor object spaces, so that we do not have to think about solving or taking care of multi-threading problems using Ractor. And we can also move objects between Ractors. Moved objects become invisible from the original Ractor. So that's that is a part of object management of Ractor. And Ractors can share shareable objects between Ractors. Shareable objects are, for example, modules, classes, and application code, and yeah, if you marked as it is shareable, and definitions like constants, settings, configurations, and many others. But what does shareable mean? And shareable objects should be marked by makeShareable method of Ractor class. Those objects will be frozen in most cases, but the proc, the shareable proc is a kind of special thing that is isolated proc. MakeShareable method makes proc objects isolated. Isolated proc is not frozen but shareable. Isolated proc calling binding methods on isolated proc raises argument error. And all referred values from the proc object should be shareable too. And this is an example of isolated proc. The left side one is usual proc, and assigning 1 into x, and p1 returns the x plus 2. And when calling p1.call, that returns 3. And after that, we can assign 5 into x, and then p1 returns 7, because x1 is referred by a proc p1, so that the x was updated, then p1 called. But isolated proc, but the case of isolated proc, assigned the value 1 will be kind of frozen, and when the proc object p2 was marked as shareable, p2 is now isolated proc, and the value x will be not updated in the context of p2. So even when x will be updated to the value 5, like this code, but then the return value of p2 will be not updated. That will be still 3. But the isolated proc isolated proc cannot refer the unshareable object. In the first example, S1 is the value of S1 is a mutable string, and mutable string cannot be shareable object, so that when we will call make shareable on P3, that will raise isolation error. But if the string object S2 will be frozen, the P4 can be marked as shareable, isolated. This is a feature of Ractor, but the main point about Ractor is speed, because the Ractor is to run Ruby code in parallel on multiple CPU cores. But how fast is Ruby with Ractor? Yeah, we expect that that should be n times faster if the laptop has n CPU cores. But is it true? Is it true for web applications? Is that faster than the n processes by fork? Does my web application run faster with Ractor than the current deployment? Yeah, speed is very important. So what we need is experimental application server using Ractor. And that should be a rack application server that can support rack application protocol between server and applications. And that should have processing workers on Ractor to receive established connection, to read request, to run your rack application, and then to write response. And of course, it has speed and an appropriate performance with less overhead. Yeah, speed is very important, and that is write speed. I'm very sorry about my terrible English pronunciation, and that is not write speed, but write speed. That is an application server written by myself, and that's right now that supports a very limited feature of rack application server, but we can try to run rack applications on that. And yes, we can execute rack app using this write speed server and with your rack app configuration. And if you want, we can specify the number of workers. Default number of workers is equal to number of CPU cores. So yeah, you can use write speed without any special consideration. Yeah, let me show the demonstration about write speed. This is very simple rack application that will send a response 200 with OK, just a string OK to any request. And now I will launch our Webrik server with this application. Yes, that can run. And also, we can run this application using write speed. Okay, cool. Now that's started running with 8 workers. And yeah, that shows the warning Ractor is experimental. And now it's listening this port. We can send a request to that endpoint and got a good response. Cool. That is a rack server, web rack server, so that we can run a Sinatra application. We should be able to run Sinatra application like this. Yes, rack up this application like this, and boom. That is because Sinatra framework has so many unshareable objects, logics, settings, configurations, and many features, many unshareable features, so that I couldn't resolve all problems about Ractor safety right now. And even with so much monkey patch code to override methods, override constants, and many others. But right now, Sinatra applications cannot run on write speed for now. And I have a Rails application, and that can't run on write speed because this very huge Rails application object, huge object. Yes, this huge object is also unshareable object because that have many reference to unshareable objects. So yeah, we need many patches on Sinatra and also on Ruby on Rails. Anyway, the important thing is, yes, actual traffic. Let me show the demonstration about the benchmark traffic, because the speed is very important. And execute rackup using write speed, and then execute a very simple benchmark tool with just single connection and thread during 3 seconds. Okay, that can process traffic requests, 5,000 requests per second. That is good. And now I will run very similar traffic using 2 connections, 2 threads. Oh, boom. That is our segmentation fault. Sorry, that is our crash of Ruby runtime. Yeah, Ractor is now experimental feature, so that should happen. Now 5 p.m. Cool. Anyway, yes, there are so many problems about Ractor, about running web applications on Ractor. I believe that that crash will be fixed later. I will try to work on this problem after recording this session, but I'm still unclear about the root cause awarenesses. The other one is module or class instance variable accesses. That is prohibited and from non-main Ractors right now. If we will read module or class instance variables from Ractor calls, it causes isolation error. And many frameworks like Rack, Sinatra, Ruby on Rails are heavily using that module or class instance variables, so that should be avoided. And also, many libraries are using that feature for default instances or default options. For example, JSON.damp cannot be called in non-main Ractors right now. And those limitations will be removed, and leading module or class instance variables will be allowed in the future, not fixed yet, but will be allowed. And accessing unfrozen or unshareable constants, that is another problem. Yes, that will raise exceptions. And constants can be accessible from Ractors, but those variables, those values should be shareable. So if so, the value 1 is mutable string, not bad, not good. Value 2 is a hash object, unfrozen hash object, not good. And value 3 is a frozen hash object, but containing a mutable string. That is not good. The value 4 is a frozen string, and value 5 is marked as shareable. That is bad, I think. Anyway, but if you using a frozen string literal magic comment, yes, value 6 is okay and value 7 is okay. So my recommendation is to use magic comment, frozen string literal magic comment always. And for hash and array objects, I want a variant of magic comment, for example, frozen shareable constant literal, or kind of for hash or array values assigned to constants. That can help us to write Ractor-ready code. And define method is another problem. The methods can be called in Ractor usually, but methods defined by define method may cause errors because procs are unshareable in default. So if you use define method in usual way, that will be unshareable method definition, because the block is not block is unisolated block. So that's this code will raise runtime error in Ractor. Frameworks, Ruby on Rails, Ractor, and many other frameworks are doing define method everywhere. So that is the hard thing. And so Ractor safe methods with shareable isolated blocks can be defined like this. But it is a little too long, a little too complicated, so that we need a kind of shorthand like isolate method or kind of, or yeah, another magic comment like isolated lambda liter or like that. That will make our that will improve the productivity of writing Ruby code, Ractor safe Ruby code. So there are so many things, so many right things to be done. We need to check Ractor safe, our applications are Ractor safe or not. And frameworks, libraries, we need many patches to make those things Ractor safe. And also we need so much works patches on Ruby runtime to make Ractor production ready. More Ractor safe core libraries, more Ractor features. For example, we cannot kill or stop Ractors from outside. And more features about productivity. For example, new magic comments or any others. Yeah. That means there are so much contribution chance. Yeah, we have so much spaces to write many patches on Ruby core or many major libraries. So yeah, let's enjoy writing patches on those, and we'll get much better performance on our web applications. Thank you very much.